This is example number 2 in lesson 7.4, linear and nonlinear functions in the real world. And our objective is to recognize and analyze linear and nonlinear functions in the real world. Okay, so example number 2 says, a student is completing a homework assignment. Each minute, the student records the number of problems left to complete. The table shows the data. All right, and they're asking us 3 questions. What is the rate of change of this linear function? What does the rate of change represent in this situation? And then, after how many minutes will the student finish the homework assignment? All right, let's look at the table. It says homework assignment, and then it says time in minutes, so the units are minutes. And then it has 0, 1, 2, 3, 4, and 5 minutes, because remember it says each minute the student records. Then it has the problems left, and it says 21, 18, 15, 12, 9, and then 6. Obviously the problems left are going down because he's completing them. So one thing we can analyze about this table here, this function, is that it says at 0 minutes there's 21 problems left. Meaning at the start of him starting the assignment was 0 minutes, there's 21 problems, meaning that that's how many problems were on the assignment to begin with when he started recording the number of problems. Okay, for us to figure out the rate of change of this linear function, we have to figure out what is our input and what is our output units. And remember, I told you that the input is like the cause and the output is like the effect. So for instance, because time and minutes are passing and he's completing the homework, then there's a certain amount of problems left. Okay, the problems left depend on the time passing. So because time passes, that's your input, then the problems left are going down. That's the output. Okay, remember, the output is always a function of the input. The output depends on the input. So the problems left depend on the time passing. All right, now we have to figure out the rate of change. Well, we know that the rate of change is the change in output, so copy this down, over the change in input. Okay, and so let's take a look at our table again. So let's do the input first. It says that he's recording each minute. So to go from 0 to 1, you're going up a minute, plus 1. Then from 1 to 2, he's recording again after a minute. From 2 to 3, it went up a minute. From 3 to 4, it went up a minute. And then from 4 to 5, it went up a minute. All right, so the change in input is 1. It's constant. Now let's figure out the problems left, the change in the output. So to go from 21 to 18, you're going down 3 problems. From 18 to 15, you're going down 3. From 15 to 12, you're going down 3. From 12 to 9, you're going down 3. And then from 9 to 6, you're going down 3. Okay, so he's going down 3 problems each minute. It's constant. The change in output is constant. So we know that this is a linear function. If you were to graph these points, these ordered pairs, 0, 21, 1, 18, 2, if you were to graph these ordered pairs, it would be a straight line because this is a linear function. The change in input is the same and so is the change in output, so it's a constant rate of change. So here we have, what is the rate of change of this linear function? Well, we know that the rate of change is the change in output, which in this case is -3, over the change in input, which in this case is +1. -3 over 1, or -3 divided by 1, is -3. We just answered what is the rate of change. Now they want us to analyze, what does the rate of change represent in this situation? Well, we know that it looks like the problems are going down by 3 each minute. So the rate of change, -3, represents, okay, that every minute, right, because he's recording every minute there are 3 fewer problems to complete on the assignment. Okay, there's 3 fewer problems to complete on the assignment because he's doing 3 each minute. Okay, so that's what the -3 represents. That every minute there's 3 fewer problems to complete on the assignment. Now we have one last question. After how many minutes will the student finish the homework assignment? Okay, well, for us to figure that out, we know that, like we said, at 0 minutes there were 21 problems. So at the start of the homework assignment there were 21 problems. And for him to finish it, that would mean that he has to have 0 problems left on the assignment. So basically what we want to do is we want to extend the table until we get it down to 0 problems, because that would mean that he finished it. So let's go up, let's extend the table, right? We're kind of predicting here. All right, and he's recording each minute, so we have 5 minutes. So let's see at 6 minutes. At 6 minutes, if we went up 1, we're just following the change in input. Let's do the change in output is -3 each time. At 6 minutes, he would have 3 fewer problems, so there would be 3 problems to complete. All right, we're not down to 0 yet. Let's extend the table again. At 7 minutes, if you were to add another minute on, then let's do our change in output is -3. Well, if he has 3 problems and it's -3 is the change, then it would be down to 0. So here, when we have 0 problems to complete, it's going to have been 7 minutes that passed. So after 7 minutes, there's 0 more problems to complete, which means that it will take the student 7 minutes to complete the homework assignment. Okay. Because it's 7 minutes, there are 0 problems to complete. He's finished it. All right, now that you have taken notes on both examples, I want you to try the Got It. We have one Got It today, a real world example.